here we're going to look at some introduction ideas to inverse functions. So first and foremost, the biggest piece that you have to get used to is that inverse functions has a brand new way of denoting a function. So this -1 right here does not mean to the power of -1. In this case, it means inverse function. Okay, so inverse is essentially interchanging the first and second coordinates when we're talking about ordered pairs. So if I have these ordered pairs here, 2, 3, 4, 5, -2, -1, and I wanted to write the inverses, then in order to do that, I just simply would interchange the x and y coordinate. So if you were a y coordinate, now you're the x. If you were the x coordinate, now you're the y. So this becomes 3, 2. It becomes 5, 4. And -1, -2. Okay, and then close your bracket. Now that same idea gets carried into equations. So instead of just interchanging your x and y coordinate with each other, here we're going to change the x and y variable with each other. So in this case we have f of x equals 2x plus 3. So the inverse is going to say now that we have x equals 2y plus 3. And in this case, what we have to do is we need to remember or recall. So we have to recall your notation. So this right here, your f of x, you need to recall that f of x means y. Okay? And so we just simply interchange that x and y position. Okay? Now, as a side information, when we're talking about inverses, now we are talking about using the reflection line. Usually the line is going to be y equals x. So that's this dotted line right here, where y equals x. Okay? And we call that the reflection line, and what happens is our inverses are generally going to be a reflection over that line. So whatever your beginning equation is, and wherever it's graphed, when you reflect it over the xy line, that's where your inverse is going to show. So to demonstrate that, we've got this example here. And in this example, what we want is we want to graph the original, and then we want to graph the inverse. Okay? Now, whenever you're working with inverses, knowing that it reflects over your xy line can be very helpful. However, you do need to make sure that you can always identify your ordered pairs that exist within your inverse. Okay? So here I have y equals x squared plus 1. So the very first thing that I would do is I would go ahead and I would graph. And you can graph anywhere, any way necessary. A couple ways to graph is you can make the XY table, or you can use your slope and y-intercept. Okay. Either one of those methods is going to work perfectly fine in order to graph your original equation. And so here I would just go ahead and because I have this x squared here, I'd make an xy table. So we're going to have x, and then we have y equals x squared minus or plus 1. So this is going to be my table. Because this is a square, I want to pick 5 points. So I'm going to go ahead and use -2, -1, 0, 1, and 2. And so in this case, the first thing I do is I plug it in. -2 squared is 4, plus 1 is 5. So here you have -2 squared plus 1. It's going to give you 5. Then we're going to have -1 squared plus 1 is going to give you 2. At 0, we're going to be at 1. At 1, we're at 2. And at 2, we're at 5. So right off the bat, I'm going to go ahead and go in and graph. Now, if you are not in a position to where you can use multiple colors, then you want to make sure that you definitely identify your graph by writing the name of the graph somewhere near the graph itself. So here I'm going to use colors, but I'm also going to show you how to identify by labeling your graph. So I'm here at 0 and I'm up at 1, so this is my first point. Then at both -1 and 1 I'm over at 2, so 1, 1, 2, and over at 2. And then at my 2 values I'm up at 5. So 1, 2, 3, 4, 5, and then 1, 2. So I'm going to go ahead and connect my quadratic, and it's going to go up like this, and then through the other side, again, kind of go up like that. So I've kind of used a color, and so here I would label this as y equals x squared plus 1. Now what I'm going to go ahead and do is I'm going to change my color. And in this case we have to do the inverse. So I have y and x squared, and remember inverse means to interchange it. So in this case my inverse is going to be the equation x equals y squared plus 1. Now just like with my top, I'm going to go ahead and create my table. And so here in this case I would have that x equals my y squared plus 1 and y. And so here my inverse, I'm going to do the opposite. I'm going to choose my y values to find my x values. Okay, so here I'm going to use -2, -1, 0, 1, and 2, just like I did for my original graph. And then just like the original graph, I'm going to plug them in. So in this case, again, this is -2 squared plus 1, which gives me 5. We're then going to have 2, 1, 2, and 5. Okay. Now, if you look at these two tables, notice they do follow the definition of inverse. Remember we talked about how your coordinate points, you switch your x and your y coordinates. So if you look at these two tables, notice that is exactly what has happened. If it was an x, it became the y. If it was the y, it became the x. So we're going to go ahead and graph the points we have. So we are first at the point 1, 0, so that's on my x-axis, so we're right here. Then we have when x is 2, we're at 1 and -1, so 1 and -1. And then out at 5, so 4, 5, we're up at 2 and -2. So I'm going to go ahead and draw this graph going this direction and down going this direction. And so here this one was x equals y squared plus 1. Okay. Now if you look at these, notice I do have my reflection line graphed right here. So if I were to fold this on top of each other, one of the things that you would notice if we were to fold our paper is that your two graphs would line up with each other. Okay? As long as that happens, then you can safely say that you have accurately graphed your inverse function. So if you have any questions about the introductions into inverses, please let me know. Otherwise, I do hope you enjoyed this short introduction video, and I'll see you next time.